Hey everyone, welcome back to this master series on learning coding patterns. My name is Muhammad Ali and today we are going to start a new approach. Today's approach name is dynamic size sliding window approach. Previously we have seen sliding window, which was fixed size sliding window approach. Then we saw 2-point approach, and now we are starting dynamic size sliding window. Okay, so Ali, how it is different than fixed size sliding window? First of all, the name itself says that in this approach the window size will be dynamic, which means that it will not be fixed. It can vary, it can change depending on the question, depending on the requirements. Okay, now how we are going to use it and how it is going to benefit us, let's see. So today we are going to solve question number 209, minimum size subarray sum. And what this question in simple words is asking, given an integer array of numbers and target number. So what we are basically given, we are given this integer array of numbers and we are given this target number. And what we need to do, we have to return the minimal length of a subarray. Okay, it means like there will be subarrays, and we have to return the shortest subarray whose sum is greater than or equal to target. So whose sum is either equal to 7 or greater than that. Okay, very simple. Cool. Now we have two approaches to solve this question. We can, using the naive approach, we can use 2 pointers, which we saw previously. So in this regard, in this case, 2-point approach will be the naive one. How? Let's see. So we have this left here and we have this right here. Okay, so we are going to start both left and right from the 0th index. Now what we are going to do, we are going to move right further and further. We will start checking from this position and then we will keep moving it unless and until we find the sum which is greater than the target or equal to it. Okay, so what's the problem with it? The problem is like using 2 loops and creating the time complexity of O of n square. Okay, now I won't discuss the time complexity now because I got a response like discuss time complexity when like you are done with your code. So right now let's see like what's the problem here. Okay, so here the thing is that we are starting from left at the 0th index and right is also present at the 0th index. We are looking at the naive approach at the moment. Okay, let me write it. So this is the naive approach. Okay, now what we are doing here, we are pointing, both of the pointers are pointing towards this 2. So at the moment we have this 2, so let's move right 1 step forward. So now if you look at these 2 numbers, the sum is 5. Okay, so what we are going to do, we are going to forward this right once more. So now the sum will be 6. Okay, these 3 will be 6. Now still we are behind that target, so we will move this right furthermore. So the sum will be 8. Okay, it's 5 plus 6 plus 2, so 8. Okay, now we have found out that yes, this subarray is greater in this subarray is producing the sum which is greater than the target value. So what we have to do, we are going to update this array length. I am removing the infinity part, so we are going to start from the infinity. Now I am removing it and we are going to update it with the length. So the length is here 0 1 2 3, so it means there are 4 elements. Okay, in simple words, the formula can be right minus left plus 1. Okay, so there are 4 elements in this subarray. Okay, now what we are going to do, we are going to update whenever we will find either 7 or greater than 7. So what we are going to do, we are going to update left to move 1 step forward, and then right will start just from left. Okay, so let's come here, remove this thing, And then what we are going to do, we are going to look at this 3. So at the moment it is pointing towards 3. 3 is lesser than 7. So what we will do, we will move this right one step forward. So 3 plus 1 is 4. Again we are again the sum is less than 7. So what we will do, we will move right one step forward, and 3 plus 1 is 4. 4 plus 2 is 6. Still we are behind, so let's move one step forward. So 6 plus 4 is 10. So the sum of these 4 numbers, this sub array will be 10, which is greater than 7. So what we will do, we will look at the length of this sub array. So the length is again 4 values, 1 2 3 4. Okay, so what we will do, we will do nothing because we already have array length of 4. What we want is the minimal length. Okay, so what we will do, we will come again, just remove this part, and now move one step forward this left and start right from it. Okay, so now let's see the optimized approach. So let me remove this one here, and now we are going to look at the optimized approach. Okay, so how the optimized approach will look like, again we can use left or right pointers to show you, but rather than considering them as 2 pointers, consider them as 2 hands of a bucket. Okay, now what do I mean by 2 hands of a bucket? Simply if you look at a bucket, so how this is how a bucket looks like, right? So this is the, you can say, left hand, this is one is the right hand. Okay, and in this bucket will contain the sum, you can say, in our case. Okay, so this is how I am pointing towards as hands, left hand and right hand. So again we are going to start left and right from the 0th index, but rather than these pointers pointing towards individual items, what they will represent, let's say if right is present at this position, so what they will be representing, they will be representing the sum of all the elements in between. Okay, so for example, what I'm trying to say is that let's say left and right started from this 0th index. Okay, now what we are going to do, we are going to keep moving our right forward towards the our right pointer towards the right side unless and until we will find target value. If we will find a sum that is equal to target or greater than target, then what we are going to do, then we are going to move left one step forward, and we are going to move right. Then we are going to check whether the sum of the sub array even after moving left is equal to or greater than sum. If it is, then we are going to change this array length. If not, then we are going to move right one step forward. So we will use right only when the sub array sum is less than target. If it is equal or greater than target, then we will not use right. What we will see, we will first see the sub array, and then we will move left, and then we will look whether even after moving the left pointer, whether the sum remains equal to or greater than target or not. Okay, let's see, like I'm going to show you how things will look like. I'm just telling you to build an intuition. Okay, so, and this is how dynamic size sliding window approach will work. So we have left and right starting from the 0th index and they are pointing towards 2. So right now our sum is 2. Okay, now sum 2 is less than 7. So what we will do, we'll move right one step forward. Now the sum will become 2 plus 3 5. Again it is less than 7, so we'll move one step forward. 5 plus 1, now it will become 6. Again it is less than 7, so it will move one step forward. 6 plus 2 8. Now the sum is 8. So what it is representing, now we have 8 in our window. Okay, cool. So 8 is greater than 7. So what we will do, we are going to update our array length 4. So I'm not writing 4 here, but imagine like we started from infinity. Okay, let me do this. So here we started from infinity, but we don't now we have this array length which is greater than our target. So what we are going to do, the sum is greater than our target, so we are going to update it with 4. Okay, 4, right? So now what we will do, rather than just moving left one step forward and then starting right from the very position of left and continuing that right to the very end, what we are going to do, we are simply going to move this left one step forward and use this sum. Okay, so if I minus 2 this from 8, so what will become, so this subarray's length, this subarray's sum will become 6. 6 is less than our target. Now after checking, yes, 6 is less than our target, so what we will do, we are going to move right one step forward. And when we will do such kind of thing, what will happen, 6 plus 4, so only one element has been added here, so the sum will become 10. Okay, now we have got 10, which is greater than our target, so we will look what is the length of this sub array. This is 1 2 3 4, so it is again equal to the length we have already seen, and we want to find minimal length. So right now we are not going to do anything. Okay, we are fine, but now we are going to change this left one step forward. Again, I'm not touching right at the moment. Why? Because what we will do, we are going to look at these 3 elements first. So the previous sum was 10, we have removed this 3 here, so what remained is 7. Okay, 7 is equal to our target. Now this is a subarray, and what length does it consist of? The length is 3. So what we are going to do, we are going to update our array length, because 3 is less than 4, and we want to find minimal length, right? So we have this 3 here. Cool. Now what we will do, again, at the moment the length of this sub array is 7, these 3. Okay, so what I will do, I am going to move this left one step forward. Now the length will become 2 4, so the length will become if you remove 1 from it, it will become 6. 6 is less than 7. Now we have less than 7, so what we will do, we will move this right one step forward. Once the right will move one step forward, what we will do, we will add this 3 to this 6, so the final result will be 9 here, right? And this is not the final output at the moment. Just the sum of these 3 elements or this subarray is 9. Okay, 4 plus 2 is 6, and 6 plus 3 is 9. So what we will do, 9 is greater than target, so we are going to look at the size of this subarray. Size of this subarray is 3, which we have already seen. So we will do what, at the moment we are not going to change array length, but we are going to move this left, because we have to check whether there is a shorter array or not that can satisfy our requirement. So what we will do, I am removing this mess and I am writing down 9 here, which was the sum of these 3 elements in this subarray. So come here and shrink this array, this subarray. So now we are going to look at these 2 elements. So 9 plus minus 2, because we have removed this one. Okay, so 9 minus 2 will become 7. 7 is equal to our target. So now we are going to look at the length. So the length is 2. Okay, I forgot to move this left here. So length is 2. So 2 is lesser than the array length that we have previously seen, which was 3. So what we are going to do, we are simply going to remove this 3, and we are going to update this array length with 2. Cool. Now what we will do, we will again check whether this one element will satisfy our requirement or not, because we have this 7 here. So what we will do, so here we have 7, and let's remove this 4 from here. So we will be left with 3, just 3, when I will do 7 minus 4. Okay, so 3 is less than our target. So what we will do, if there was any other element, so right would have moved to that part, but at the moment we don't have any element here. So what will happen, our loop will break. Okay, so this is how the solution will work. I hope like you have got the idea how things will work, how the dynamic size of the window will occur. We have already seen here, like, okay, initially we started from this, but then the window expanded, and then when I looked at on other position, for example this position, so here the window size was 4, but here the window size was just 2. Okay, so you can see the window size is expanding or shrinking depending on the use case, depending on what element we are getting. So this is how dynamic size sliding window approach works. Now let's look at the coding part, how the code will look like. So here we have this question 209 minimum size subarray sum. Okay, and now let's start solving this part. So initially we are going to start with left, so the left hand will start from 0 index because we started both of the hands from the 0 index, so left equals to 0. Then what we are going to do, we are going to define our window sum. So window sum will initially be 0, and then we are going to define our result or final output, whatever the name you want to give it, and this part will be initialized with math.inf. Math.inf means infinity. Okay, so we are starting from infinity because they say positive, in order to avoid any kind of confusion, I could have started with 0, but we want minimal length. So let's say if there was any other length, and you will see the code logic down there, so you will find out if I would have started with 0, so what would have happened, like let's say minimal length was 4, and when I would be using, when let's say I will use min, then it will compare and it will say, okay, 0 is less than 4, so it would have written like a mistaken code, a mistaken result. So that's why I'm starting from math.inf. Whatever the minimal length it will find, it will update it with that let's say that result or that subarray size. Okay, you will see the code, trust me. So here for I in range length, and then we have this nums, so nums. Okay, so what we are going to do, rather than I, let's say right. Okay, so now right is also going to start from 0 index, left will also start from 0 index. Okay, these two hands will start from 0 index, just as we saw in the visualization part. Now what we are going to do, we are going to update our window sum, and with which value we are going to update our window sum, we are going to update it with right. Okay, so if I scroll down, so this was the example that we saw in the visualization part. So here what will happen, initially window sum was 0, so in the first iteration window sum will become 2. Okay, then it is going to check, and till when it is going to check, we will see. While window sum is greater than equal to target, let's say if the window sum is greater than equal to target, so what will happen, and if it will not, so what will happen. So let's say here there was 8, so what will happen if window sum is greater than equal to target? So what we are going to do, we are going to update our result. So result equals to min result comma, and I told you the equation of finding the length of the subarray, which will be right minus left plus 1. Okay, so this will tell the length of the subarray at hand, or you can say. So here this condition will not work because 2 is less than our target. So but let's say here, let's say it was 8, so what would have happened, if that was the scene, so it would have checked whether it is less than our result. Yes, it is less than the infinity part, so it would have updated the result part. Now what we are going to do, we are going to update window sum minus equals nums and then left. So remember, in the sliding window we removed left first, and then what we did, we are going to update our left pointer. So we removed the left, let's say, from our sliding window sum, and then we are also going to update the left pointer so that it moves one step forward. And finally, what we are going to check, we are going to check if result, but before writing this condition, let's say here in this case 2 was not greater or equal to window sum. So what will happen, it will again point to this part. Oops, I just okay, so it is going to update it. Okay, so window sum will be updated with 3. So 2 plus 3 is again 5. 5 is not equal to the target is 7. So it will do, it will move one step forward, and this 5 plus 1 will become 6. Again the iteration will keep happening. So now at this position the sum will become 8. So this code will then run. So then what it will do, it will update this result with 4 because the length is 4, and then what it is going to do, just like we saw in the visualization, it is going to remove this 2 from this 8, so the sum will be 6. But again right now it is pointing towards this because we haven't updated the left. So we are going to update our left pointer. Now it will look at these 3 values. Okay, and then it will check whether the window sum after updating it is equal to or greater than the target or not. Since here it is not, so it will move forward and this line will be executed. Okay, let's say after all the iterations, what will happen finally, we are going to check whether our result is equal to math.inf. If it is, then we are going to return 0. It means like there is no sub array in the nums array that is equal to or greater than our target. But let's say if there is, so what we will do, we are simply going to return it using this return result. Simple as that. Now come here and click on run, and initial test cases got accepted. Now I'm going to click on submit, and yep, the final submission has happened, and here all the test cases have been accepted. Okay, so that was it. I hope you like this new approach, dynamic sliding window. We are going to look at few questions of this dynamic sliding window in the upcoming videos, so stay tuned and keep learning if you wanna learn. And if you haven't looked at the previous videos, so we have discussed a 2-point approach and fixed size sliding window as well. So you can look at the playlist in the description, and it contains all the videos. I am trying my best to make out time to continue this series, so please keep continuing your support, and I am truly grateful for that. Thank you so much for watching this video. I hope you like it, and if you haven't subscribed yet, please do consider subscribing so that it can remind you, it can update you or notify you with the new videos that will come in this playlist. So thank you so much for your time. I'll see you in the next video. Take care. Bye.